Welcome to another exciting segment of Math with Miss Bennett. Today we're going to be discussing GCF and LCM. First of all, the GCF, it's the greatest common factor, the largest shared factor between a number pair, also known as, and this is in somewhat more student-friendly language, the biggest number that will divide evenly into both. And then also the LCM, which is the least common multiple, the lowest shared multiple of a number pair. And there's less of a student-friendly definition for LCM. This is the simpler of the two. And then why do we need to know GCF and LCM? Both of them are huge for the use of fractions. The good news is for most of you who are really good with your numbers, the GCF and LCM will be something you instinctually know. I'm giving you methods to solve these when you don't instinctually know the GCF or the LCM. So the first way to do GCF, and this is what I like to call the old school method, we wanted to find the greatest common factor of 36 and 42. So we might start by listing the factors of 36 and 42. Factors are numbers we multiply up to get the number. So you might have seen them listed as 36 has the factors 1 and 36, because 1 times 36 is 36. 2 and 18, because 2 times 18 is 36. 3 and 12. 4 and 9, and then 6, because 6 times 6 is 36. And then for 42, we do the same thing. 1 times 42, 2 times 21, 3, a bit more challenging to calculate, 3 times 14, and then we would check for 4, but 4 doesn't divide into 42, nor does 5, but we also have the math that 6 times 7. And you could see them listed like this. In class, I like to list my factor pairs with a slightly different appearance because I like things to look nice. So I tend to list them like this. It feels a little bit more to the student's preference, and it reminds you that you're multiplying these numbers together in order to get the product. And that is how factors work. They are the numbers we multiply to get a product. Or some people will say the numbers we can divide evenly into those. And then for the old school method of finding the GCF, once you've listed all the factors, you would simply need to pick out the largest one listed. In this case, the largest one I see that they share is 6. And then here we could pick also 6. So the GCF of 36 and 42 is 6. And this is a perfectly valid way to solve a GCF problem. There's another method that works a lot better if you struggle with remembering all of your factor pairs. If you miss even one pair, you could get the problem wrong. So we also talked about what's called the Venn diagram method. We simply start by finding the prime factorization by making a factor tree. And factor trees can be done multiple different ways, but I like to divide by prime numbers like 2, 3, and 5 until I can't anymore. So 36 divided by 2 would be 18. 2 is a prime number, so that part of the tree is done. 18 isn't prime, but 18 can be 2 times 9. 2 is a prime number, so that part's done. 9 is 3 times 3, and 3's are both prime, so that tree is complete. The prime factorization of 36 is 2 times 2 times 3 times 3. If you take a minute and do that math, you'll see that 2 times 2 is 4, 3 times 3 is 9, 4 times 9 is 36. We do the same thing for 42. 2 times 21. 2 is prime, so that tree is done. 21 is not even, so we can't divide by 2, but I can divide it by 3 for 7 and 3, which are both prime numbers, numbers for which the only math facts are 1 times that number to get there. So what we would do for the Venn diagram method is we would then draw a Venn diagram so we can organize our information, placing 36 and 42 here, and this middle category is where you put both. Let's clean that up a little bit. So we're going to look for the numbers that our numbers share, the factors that are shared between 36 and 42. Well, first and foremost, I will notice that 36 and 42 both share a 2. So I'm going to put that in the both section of my Venn diagram. I'll also notice, and I'll draw a comma here, that they share a 3. So I'll put that in the both section of my Venn diagram. It's helpful at this point to list the unshared factors. For instance, 36 has a 2 and a 3 that aren't shared. I call them the lonely ones. And 47 has that lonely 7 that isn't shared. To calculate the GCF with this method, we simply need to find the product of the numbers in the center. So you're going to multiply those two numbers in the center. 2 times 3 gives me a GCF of 6. The same GCF I got doing it the old-fashioned way. For students who don't like to list factor pairs, this is a pretty quick method. What's nice about this method is you can also use the exact same setup to find the LCM. When do we use the GCF? Imagine you had the fraction 36 42, and you wanted to simplify it. You could keep dividing it by each part by 2 until you finish, and then 3. But if I know that the greatest number I can divide into both is 6, then I can instantly simplify this fraction by dividing both parts by 6, giving me the simplified fraction 6/7. So GCF is good for simplifying fractions. LCM, the least common multiple, as done a more old school method, would be, let's take the numbers, the LCM of 6 and 10. So in order to do this the old school way, you might would list the multiples. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36, and so on. Then you'd list the multiples of 10, just like skip counting in elementary school, counting by 6s and counting by 10. The official name for this is multiples. 10 times 1, 10 times 2, 10 times 3, 10 times 4, 10 times 5, 10 times 6, and so on. Here you already see the least common multiple is 30. They both have a 30. The reason we look for the least common multiples is because multiples just keep going. In fact, if we continued that list of 6 all the way out to 6 times 10, we'd eventually get to 60 and find that they share 60 as well, but it's not the least common multiple. What's nice about doing the LCM via the Venn diagram method is you already know how to do the LCM. You already know how to do GCF. Now you can do the LCM. So we're going to say of the same 6 and 10. You simply start with the factor trees. 6 is 2 times 3. Notice that the numbers tend to be smaller for LCM, so the factor trees are fast. 10 is 2 times 5. So again, you're going to set up the diagram, have your both section, your 6 section, and your 10 section, what they share and what they don't share. I see that both numbers share a 2. So I'm going to place a 2 in the center. 6 has that lonely 3 that isn't shared, and 10 has that lonely 5 that isn't shared. To find the GCF, we were multiplying just what's in the center. To find the LCM, we're going to multiply everything. The LCM is equal to 3 times 2 times 5. 3 times 2 is 6. 6 times 5 is 30. The same answer we got before, just a different method. But why do we need to learn about the GCF and the LCM? What does LCM do for us? Well, let's say you needed to add the fraction 3/10 and 5/6. So in order to add those two fractions, you would need a common denominator. We could multiply 10 by 6 and get 60, but it would be much easier to use the least common multiple of 30 to find the common denominator. So I would say 30 times 3. 30 is 10 times 3, so 3 times 3 is 9. 6 times 5 is 30, so apply the same. 5 times 5 is 25. And then I'm going to use that relationship that I picked up on to write a new problem. 9 plus 25 is 34/30, which of course we could change to 1 and 4/30 and simplify that again to 1 and 2/15. But without the LCM, we would have had a much larger fraction problem to simplify by proportion because we would have been working with 60ths. By using the least common denominator, we don't have to simplify our answers nearly as much. So a quick recap of GCF and LCM. Both are useful for fractions. The GCF helps us simplify fractions, and the LCM helps us find common denominators when adding and subtracting. You can do both of these with old school methods or with a Venn diagram. Remember when working with a Venn diagram that the GCF is the product of the center, and that when doing the LCM is the product of the entire diagram. I hope this video was helpful, and thank you for joining this exciting segment of Math with Miss Bennett.